welcome to today's session, and we will be discussing about MCP. I hope you can hear me, and I hope you're ready to learn. We have four sessions today, and we kickstarting on the first one, which would be developing the best practices for MCP. And to take us into that would be Mr. Promise Owanchuku. I'm just going to read his bio so that we can know who we'll be learning from today. Um, he's an accomplished consultant in cloud and DevOps. He specializes in building secure infrastructure, and also apart from just building secure infrastructure, he's also he has great knowledge in AI and Azure AI. And so today we'll be looking at MCP, and he'll be teaching us how to develop the best practices on that. So I will be bringing him right. But just a promise. Hello, hello. Can you? We can't see you yet. Okay. So while we're waiting for Mr. Promise to turn on his camera, I'll be walking us through some of the things I'll be learning in this session. First, we'll be learning how to create comprehensive testing strategies for MCP servers. We'll be learning how to design reusable workflow patterns for MCP applications, right? So these are things to put your mind into. And I believe that if you're coming here, maybe you already know some of the basics for using the MCP, because this is like a session to make you better, right? So Mr. Promise, are you ready?
Hello, everyone. Hello, Dami. How are you
Hi,
doing
hi,
today?
hi. Welcome, welcome, welcome. We're glad to have you. We're looking forward to learning a lot today.
Awesome, awesome, awesome,
Yeah,
awesome. Thank you very much for that wonderful introduction, by the
you're welcome. So our expectations are off the roof already. Yeah.
way. Well, actually, I'll be talking on a wonderful topic. I think
Oh,
I'm still maintaining the practical implementation part, but I mean, I think this has been really awesome because we've had a pre session where we spoke or gave some intro about MCP, and it will be awesome to just see how do we actually practically
implement them.
this. Yeah,
All right. So just to go over this again before you start, what are our expectations for practical implementations of an MCP server?
I think one of the things you should expect generally is understanding how to make use of MCPs. How do you integrate MCP tools into
Okay.
your agents, and how do you make your agents or your applications collaborate with MCP tools? So generally, extending the functions of your applications or your agents to collaborate with MCP tools, and yeah, get real life insights
All right.
through your MCP tools.
Okay. So that's like the summary of what we're expecting this session, and I'll leave Mr. Promise to get right into it. Thank you so much.
Awesome, 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 awesome. All right. Thank you very much all for giving me this wonderful opportunity. I mean, I remember when I was actually sitting down to do a presentation about this. Um, I was I had to do some research as to how things work and all of that. And I must tell you, it was really, really a an interesting process because when you prepare for things like this, it gives you a better insight as to how things work. Today, I don't just want to focus on the theory. I really want to be able to talk about the practical things we can practicalize and how we can work with them. That's what I really want to do today. So let me share my screen and then we can proceed. Yes, screen share. Good. Please let me know if you can see my screen. All right. So Today, like I mentioned, we are looking into the practical implementations of MCP servers, a comprehensive guide to building, deploying, and integrating model context protocol servers for enhanced AI capabilities. So, some of you all will have been wondering, what is really this MCP thing about? Why? Why is the waves? Why has the waves been going about MCP? What is different from what we used to know and current MCP? Well, today I actually want to speak on or show us 5 ways we can practically implement this. And I believe by showing us how this works, we would have a better understanding on how to work with MCPs and all of that. Awesome. So let's go to just a short intro on MCPs, and then we proceed to a practical demo session. So, firstly, you may be wondering, what is MCP itself? I would say MCP, or Model Context Protocol, are generally servers that enable AI applications to securely interact with external tools. So if you have your AI applications running and you want to ensure, or you want to enable your applications to be able to interact with external tools, well, MCP is one of the ways you can, or one of the things you can enable on your AI system to ensure interaction between the external tools and your application, your AI system, right? So with MCP, you enable your AI system to interact with external tools and data sources in real time. And we'll be actually seeing how all of this plays out, right? So what MCP does is that it helps to expose capabilities as tools, resources, and prompts that are discoverable by what AI clients, right? Now, in order to show you how this works, I'm actually going to be um what's the word? I'm actually going to show you a quick demo on one of the things we can do regarding this. So I would show you how you can practically, let's say, extend your tools, right, or extend your AI systems, right, making use of MCP and its tools. The first practical session we'll be looking at regarding this is what I call a setup like this, right? So, basically, in this setup, what we want to achieve here is that we are going to be making use of MCP tools to actually make this happen. But what you need to have at the back of your mind is this, right? Um, your MCP server comes into play here. So I will give a brief description of this diagram, and we will go straight into seeing how all of this works. So the first thing you need to notice is this: your MCP inspector is like a client application. Yeah, your client, which helps you interact with your AI systems, right? And in the first setup here, what we do have is an AI gateway that serves as the point of entry. So this is the first point of entry. Anyone who wants to access your MCP servers, your MCP tools, need to first of all hit your AI gateway. Now, in your AI gateway, you can deploy policies, you can deploy systems that would ensure, right, that you are able to successfully connect to your MCP tools or MCP server. So if you see here, within the policies, they provide guidelines that help your AI gateway be protected. Now you can decide to have log metrics in your AI gateway system, to log whatever is happening in the AI gateway. Now, before anyone can connect to your AI gateway, this system has been connected to an Entra ID, which will therefore provide you with the acknowledgement. So before you can come in as a user, you need to first of all be acknowledged that you are an actual user in that system, right? Before you can be able to interact with the MCP servers. So that's what the Entra ID is here for. You see, there's a communication with the Entra ID. Once access is granted, the user is then able to communicate through the AI gateway to the MCP servers. Now, the function app here generally just holds the necessary tools, right? So, without further ado, we are going to actually look at a practical system, and then we'll come back and look at the next example, and we proceed in that order. All right. So to look at this example, I'm going to be showing you this. Yes, this. So I'm just going to be logging into my Azure system, just to show you a practical setup of what we have just discussed. So awesome. So in this setup we have just discussed, this is the resource group that contains the setup. So I will be showing you between the diagram and the setup, so you have an actual view of what is going on. So just as you can see here, the Azure API management here, that's what we have here. This is the resource responsible for that. Maybe I make my screen a bit bigger. This is the resource responsible for that. It's called an API management system, right? Azure API management system. So you can see it here, Azure API management service. This is what you see here, right? Also, some of these other systems you see, like the function app, the container app, you can see all of that here. So here is your function app hosting your MCP server, or your the function app here is hosting the MCP server, and then you can see also some basic applications that would help the interaction go into play. Now let us actually implement this and see how does this work. Now, for us to first of all implement this, we need to interact with our terminal, right? So I'm going to bring the terminal over here. Yeah, let me see this. Yeah. Okay. Let's see. This is my terminal. Okay. My terminal comes into play here. Just a moment. All right. Yes. So the terminal is coming up. Just a moment. Just looking to this. Okay. Here. Okay. So good. Okay, let me do something like this, and I would escape this for a moment. Good. Okay, I can now have this. Yes, so I have my terminal as big as this. Good. So for our terminal interaction, just like I should, to be able to implement something like this that you can all see, I'm going to proceed now with the setup. So all I need for this is to run a little command which will initiate the I would call it the MCP inspector tool. So basically, what I want to do with this terminal is to initiate this MCP inspector tool, right? And for me to do that, I just need to run this command. I just need to run this command on the terminal, npx at model context protocol slash inspector, right? So that would enable the launch of the inspector tool. So you can see this. This is now going to initiate, and good. So right now I have my MCP tool running on my browser. Here is the browser, so you can all see. Maybe I'll do this, and I'll add the browser here. So this is what the browser looks like, right? So if you're wondering, this MCP inspector tool, this is what the browser looks like, right? So the first things first, if you're going to be able to interact with the system, according to this diagram, you need to communicate with the what API gateway. So that means that the link I'm going to be having on here, the URL, has to be that of the what API gateway. And that link, you can find that link here. You can find that link here, which is this. The only thing I'm going to do is that I'm going to add a slash MCP here, right? So we are going to do just that right now. So good. The only thing I'm going to do here is I'm just going to add slash MCP slash SSE, right, to the URL. So that is, I've just copied this now, and I'm going to come to this MCP tool and paste this here. So here on the URL, I paste this. If you notice, you can see this is the same thing as what we have on here. The only difference is that I've added slash MCP slash SSE. Now, you may be wondering why slash SSE. Slash SSE is the mode of transportation. So when you're dealing with MCPs, we have three major different types. One is STDIO, SSE, and streamable HTTP, right? In this session, I'm going to be working with majorly, in this whole practical session, I'll be working with majorly two of them, SSE and what? Streamable HTTP. So now I have this done. So the next thing I should do is to connect to the gateway. If you remember in the diagram here, the first thing you need to do is to connect to the gateway. But then when I try to connect to the gateway, I'll be redirected to what? The Entra ID. Now let's see how that plays out here. So for me to connect, I need to click on this what? Connect button. And that's what I'm doing right now. Now you can see that I clicked on the connect button to connect to the gateway, but it's telling me this. It says the following application is requesting access to what? MCP server, which might include access to everything MCP server has been and will be granted access to. And then it lists all the details of the application. And then it's asking me, do I want to allow access or not? Right? So this is where it has redirected me to the Entra ID and it's asking me for access. So yes, I'm going to grant access. Now, once I grant access, let's see what happens. So you see, it's asking me to authenticate. Who am I? Right? So you can see I have just authenticated there. And now I now have, once the authentication is granted, everything looks fine, I would then have access what? To the MCP server. Now you can see that now it says connected. Right now it says what? Connected. So what it means is that I've been able to connect to the MCP server. Now you may be wondering, what are the things the MCP server is holding? The MCP server is hosting tools like this. You can see, we said the function app is acting as the MCP server here, and it has these tools: get snippet, hello MCP, and save snippet. Right now, from here, because I've been able to connect through the client, I'm going to list the tools which the MCP server contains. And once I list the tools, I should be able to get the same tools listed in here. So you can see these tools here are the same, which you now see here. Now, from the application here, I can now interact directly with the MCP server. Why? Because I have been granted access. So what we just explained now was the MCP tool connecting to the API management system, right? And being redirected to the Entra ID. Once we authenticated, it then gave us access to what the MCP server. That's what we have just seen being practicalized, right? So now I can now interact with the MCP server. The MCP server has these tools. So the first one is what Hello MCP. You can see I'm able to interact with the tool, save a snippet. So for the tool save a snippet, generally what this tool does is it just helps you to save snippets. So I can just give it a name, and I can just say the name of my snippet is PRM, right? Or I can even put a Y if I want, or PRMY if I want, right? And then I give the content of my snippet, or let me probably give a more, maybe something like a case. I can just name it case, right? And I I then say something like this case contains contains the snippets of my practical session today, right? And then I run the tool. Now, if this tool goes successfully well, it should be able to save this snippet in the storage account. So I'm having an error, right? Because let's just say this is due to a timeout. So all I just need to do in such scenarios is to reconnect, right? I just reconnect. Sometimes when you have like a delay in the system, you could have such errors. So we will do the same thing now. Now it's connected. I list the tools, save snippet, and I say case, this case snippet has the tools from my practical session, right? And I run the tool. Now you see it's a success, right? It's a success because, yeah, it was able to successfully communicate from this application to the MCP server, right? Now, because I've saved this snippet, I can now get the snippet. So I can now use this tool to get the snippet, right? So what is the snippet name we just saved? I can say case, right? And I can run the tool. And then you will see that it's going to retrieve the snippet which I had saved. So the snippet case, you can see, is retrieve the snippet for me and the content of what the snippet, right? So this is just the first practical implementation of what an MCP server looks like, right? How you're dealing with MCP tools, understanding how to work with the MCP server through an AI gateway system. Now, we'll be talking about the next practical implementation. I have about 5 practical implementations of this, and I hope that I'm able to actually complete the 5. So let's see where we can get to, and we move from there. So for the next practical implementation, yeah, so just before we went off, we were looking at what is an MCP server. Now, with what we talked about, I've been able to demo to you what an MCP server looks like, how you can interact with it, right? Now, we are looking at the next one. What will be our next practical scenario? Just a moment. So, for our next practical scenario, what we want to look at is how can we extend the functionality of an application making use of MCP protocol, right? To to be able to work with that application. Now, before we go fully into this practical session, I want to explain something to you. Yes, good, 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 good. Now, for this practical setup, yes, this practical setup that we see here, um, note that while we were taking interacting with the server here, you remember we what's the word? We initiated this connection. Now everything that happened while we were interacting with the server and all of that was being recorded here. And if you remember, there was a time we had an issue with the connection where it said some error. You can see we are getting authorization failure here, right? So when we refreshed, it automatically connected. By the time we did, what's the word I would use? When we did a refresh of the browser and we reconnected to the system, we were then able to get access. And here you can see us now interacting successfully with this server. Now, for the second setup, which I want to show to you, which is this is a weather tool. So what we were able to achieve with this is this two things. I'm going to show you three angles of implementing this setup, right? I'm going to show you three angles of what implementing this setup. So what you can see clearly now is a generative AI application built with a semantic kernel, right? Now we've been able to connect this application, or maybe you can look at it as an agent with AI Foundry, and this application is also talking to what an Azure Open AI GPT 4.1 model, right? Now, with the extension of this application and adding MCP2 with it, we are able to interact with this setup here, which is an Azure Container Apps environment that helps us to get the current weather status in all states in the United States of America, right? So this is a second setup of how to make use of or let me say a practical implementation of MCP, right? Now, to show you the first angle which we are going to be working with this, what I want to do now is I want to, right, firstly use an application like the model context protocol to interact with what this weather app. I want to use the model context protocol, the model context protocol inspector tool to interact with what this weather app. Now, to be able to achieve this, let me show you what the weather app looks like. In here, let me come here and come to this. Now, this is what the weather container app looks like, right? You can see this is the weather application, and you see that everything has been containerized and is running in this environment. Now, I want to be able to interact with this weather application using the what model context protocol tool, which we did in here. So I want to be able to interact with that environment using this. Now, for me to be able to do that, I need to come here and stop this one, right? So you can see this. I need to come here and stop this from running and rerun a new session. So I'm just going to do here Control C, and what this means is that I've what's the word? I've paused or I've canceled the previous session. I'm now going to okay, maybe let me not entirely clear everything out. Let me open a new tab and let's run the command we ran, right? Which is this command we ran was this. So, like I mentioned in this setup, what we want to do is that, oh, okay, maybe I need to source this. No, this. I'll say dot bash rc. Okay, I think what I have here is a source this dot zhsrc. Let me check what I have in my home directory. Um, okay, sorry. I think it is this. Okay, let me do this. ls minus la this. Good. So what I have here is what do I have here? Sorry, I have some shortcuts which I have done that I just need to call. Yes, ZSHRC. Okay, good. ZSHRC. Good. So clear this and source this dot ZSHRC. Good. So now I can now put up the previous command, which is this. So what this will do is that this will set up a new setup of that application, which is different from the previous one. So you see that this one is a previous session, right? Now this is going to set up a new session. So now what I want to do, like I mentioned to you earlier, was I want to be able to use this tool to interact with the weather application. So the next thing I'm going to do is that I'm just going to add the endpoint. So for us to be able to add the endpoint, it would just be something like this, but I'm going to add slash what MCP at the end, right? So this is this, and I'm going to clear this, and I'm going to put in here this. So if you look at here, you see the address has slash MCP at the end. Now, the protocol we are going to use for this will be different from the protocol we used earlier, right? And we are going to make use of the streamable HTTP protocol, right, for this particular setup. Now, the next thing we do is to connect to the weather app application. So what we're trying to do is connect to this container app, right? So I click on connect. So let's see what happens here. So now, if you see what is going on with this on this environment, we don't have an AI gateway at the back of this application. We are just doing a direct connection to this particular setup. So with this, we should be able to directly connect and list the available tools in this MCP server. So let's do this. Let's see. So good. So right now you see it says connected here. So we've been able to directly connect to those or that application. So the next thing we are going to do is we are going to list the tools in the weather app. And you can see the tools in the weather app are generally like what? Get weather alerts for the US state. So I mean, I could say um, so I'm going to provide. So I'm going to provide a list of US states, right, with just two letters, right? So we're going to click on this tool, and in here, all I need to do, right, is to provide the name of the state and run the tool, and it will give us the weather alert in that state, right? So I'll just do something like CA, right? And now it's going to communicate with the MCP tool, and now you can see. So for CA, if you're wondering what CA is California, right? So you can see now it's telling us that there's a dense fog advisory in California. The area is grapevine and its severity is what? Moderate, right? And you can see description, visibility 1/4 mile or less in a dense fog. So what this does is that it's been able to give us the weather alert, right? Right from here where we are to see what is happening in California. So this is a direct interaction from the MCP inspector client, right, to the web app itself. That's the web app where we are running the MCP server. Now, I want to also paint you another angle to this connection setup. Remember, I said I think I have about um, 3 angles to this particular setup here. I have about 3 angles to this. The first one we've done is to make use of the MCP inspector to connect directly to this. Now we've been able to connect directly to this, and we were able to get the weather alert. The second one, which we want to do, oh, someone was asking, are all of this running locally? The only thing I'm running locally is my MCP inspector tool. I'm Williams Olawuwo, right? The only thing that I'm running locally is my MCP inspector tool, which is like my client. What every other thing is running online, right? Good. So now the next view or angle I want us to look at is how about we interact with this setup, right? Making use of an agent, right? How about we interact? So the agent, basically, what we have as an agent is and just a service or an application that is having Azure Open AI GPT 4.1 model at the back end. And what it will do is that it's going to set up a kind of interaction with this server, with the MCP server. It will develop threads and will give you um it will develop threads and will give you an alert of that location. So to be able to implement this, we'll be working with the terminal in this scenario. So for this, I will just create a separate terminal, right? And firstly, I'm just going to make this a bit bigger so maybe you can see my commands. So, like, the first thing I need to do is to source. I'm going to source this. So, in case you're wondering what source is all about, sourcing is just I have some abbreviations and some endpoints or directory endpoints my system needs to call to be able to provide some commands to me, right? So that's what I'm actually doing by the sourcing command. That's what I'm doing. So for this kind of scenario, what we want to achieve, like I mentioned, is that we want to be able to interact with the web app making use of an agent. And to be able to run this agent, we just need to run this command here. Good. So we need to go to the directory where we are hosting the agent, right? So in this directory, I'm hosting the agent locally. You can see this is the directory in my local system where I'm hosting the agent, right? So I'm in the directory now. So I'm going to try to build a virtual environment from that directory that will, so that directory itself, it's more like um an environment that has the codes to communicate. And you may be wondering, what do I mean by the codes? Maybe I should show you a sample of what I mean by the codes. Maybe I would do something like this. I'll do this. And here is a sample of that environment, right? So in this setup here, what you would notice here is the directory which I went to is the AI Foundry directory, right? The directory I've gone to is the AI Foundry directory, and that's what you see in here. Now, the application I want to connect to, which is this is the agent that I'm speaking about, right? This is the agent which I'm speaking about. And in this agent, what it does generally, it creates a thread and tries to interact with the application. And if you see here, this line is where I'm giving the commands, the line 71. So you see in line 71, I say, please list the weather alerts in IL. IL means Illinois, is one of the states in United States, right? So I'm going to now build a virtual environment based on that agent and then run my command. So I'll say UV VENV. So UV is like the command I'm using for this. And if you're wondering what this means, I can just show you what it means using the help. So UVENV is only a tool that we use to create a virtual environment. So you can see it here is a tool we use to create a virtual environment. So I'm going to be running that now. I'll say clear and I'll say UVVENV. Now, what is this is doing is this is going to say a virtual environment already exists. Do you want to replace it? I'll say yes, I want to replace it. And I'll then activate the virtual environment. Now the virtual environment has been activated. Now I'm going to sync the virtual environment, which is generally more like all the installations that the environment we need to run. That's what I mean by sync. So I'll say UV sync. So with UV sync, it installs all of the packages that the environment we need to run, right? And the last thing here is generally to, okay, one moment. Yeah, so the last thing here is generally to run the agent itself, right? So I told you that this is the agent, sample agent MCP this. So to able to run that, I just come here and say UV run this. Now, what this is going to do is that it's going to run based on the command which Elias applied. Can you see here? It's creating an agent. Here you can see the agent ID, the MCP server which we are trying to connect to. Good. So you can see this, right? So when we ran the command, the first thing it did was it created an agent, and the ID of the agent is this, right? You can see it here. This is the ID of the agent. And then it tells us that the MCP server we are connecting to is this. Already, we have already put that in the code to connect to this MCP server. Now it creates a thread, right? And in that thread, the thread is something that holds the conversation, right? So once it creates the thread, it then creates a message and then now runs the command itself. So you can see the run command in progress. And what is it doing? You can see the run status here is completed. Once this is completed, what it's telling you that from the agent itself, it was able to call the MCP tool, type MCP, And here you can see, we put already there what we want to do. So here it says, here are the current weather alerts in Illinois, IL. And here you have what? Winter weather advisories, and it tells you Jefferson, Wayne, Edwards, Waybush counties, wet snow up to what? 2 inches. Slippery roads expected. And then in Bourne, Fayette, Clinton, Marion counties, you have snow up to what? 3 to 5 inches. Gusting winds up to what? 35 mph. So with this, we've been able to see how to interact with the agent or with the MCP server. With this, we were able to see how to interact with this web app, making use of an agent that creates threads, right? Now, we are actually going to now create a proper agent that we can interact with. And this is making use of the streamable HTTP protocol. Now, with the streamable HTTP protocol, we can be able to interact with this tool like we are interacting with a normal chat agent, right? So for us to be able to set that up, we are going to be making use of another setup, right? So this time around, let's create a new tab for this setup, right? So we create a new tab for this setup. And what's the first thing we do? Let's make this a bit bigger so we can all see this. Yes. So let's make this a bit bigger so that we can all see this. And in here now, what I'm going to do is I'm going to first of all source just to ensure that I have that. Yeah, so I've done the sourcing now. So the next thing I'm going to do is I'm going to connect to that agent, right? For me to be able to connect to that agent, the next thing I need to do is this. So in this case, where we are streaming, what we are doing is this: we are making use of this. So this is the agent we want to connect to, right? This is the agent we want to connect to. And with this agent, we can actually interact. Because this, what you see here, is the full setup of this. We are making use of the semantic kernel as the host. And through MCP protocol, we will be able to connect to the MCP server hosting the weather tools, right? And remember that this application is connected to AI Foundry and, of course, the ChatGPT 4.1 model. Now, to be able to start up this setup, we just need to run this command. So we need to go to the location where we have the setup. So I'm changing the directory to that location. Generally, what I'm doing is I'm coming to this location where I have the setup here. And the next thing I would do is set up the virtual environment, which we did before. I'll just say UV VEMV. So it's telling me a virtual environment already exists, but do you want to replace it? I'll say yes. So once I replace it, I'm going to activate the new virtual environment. And now you can see that the new virtual environment is activated, right? So now that is activated, the next thing I'm going to do is I'm going to then sync the application, which is basically install all the dependencies that this virtual environment needs to run, which is UV sync. So now you can see all of the dependencies that this virtual environment needs to run has already been synced. Now the next thing is to run the what application itself, right? So to run the application itself, all we need to do is to run this. So we are running this file, MCP as streamable plugin, right? That's what we are doing. So I'm just going to run the command uv run MCP as streamable plugin.py. Now it's going to set up the application for us now, right? So it's going to run the application. Now, I remember one of the guys was asking me, is this running locally? Now, this setup is running locally. This current setup is running locally. So I am building an agent locally, right? I have my files and everything locally, but the agent, or let me say the model itself, is running on Azure. I'm now able to interact with that model, making use of the API endpoint keys and all of that. That's how I'm able to interact with that model. Now, so you can see that the agent is up. And if you look at this, you can see here, it says it's making use of what? The MCP server. It was able to connect to the MCP server. Can you see this? And it's also making use of this OpenAI model, this OpenAI endpoint, the OpenAI version, right? And it can post to those locations. So it does an HTTP post to those locations and is able to get a 200, right? So this is one of the ways you see. This is one of the ways you see this application running. So now we will now test from the agent, like we are chatting. Give me the weather alert in NY. So I'm just going to say, give me the weather alerts in NY. NY is short for New York, right? So you can see now that this agent is interacting with the MCP server and is able to give me the weather alert in New York. Now you can see here, look, I want you to take a look at the interactions happening, right? When I posted the command, give me the weather alert in NY, look at what happens. It sends a post to what the model. So it was able to first of all interact with the model here, and then through the semantic kernel connector, it was able to get the necessary token it needs. And then it then proceeds to make a tool call, which is generally connecting with the MCP server. Here you can see calling the weather get alert function with arg state this. And it says invoking the function. Now it was able to connect to that endpoint with this. And here it was able to get the weather alert. You can see function weather alert was succeeded, completed, and then it passes the output from the MCP server. It passes it down to the model here. You can see the model gets that output and then pushes it out to what we can see. So here it says, here are the current weather alerts in New York. So lake effect snow warning, extreme areas, Onondaga, Madison, Southern and Anaida, right? So the next one is lake effect snow warning, extreme areas, Wayne, North Cayuga, Oswego. Snow is weakening, up to 2 inches of additional accumulation is possible. So, guys, what I've been able to explain to you is I've been able to show you practical implementations on how you can actually connect your MCP server what through MCP protocol to your AI application, and how you can interact through your agent, probably hosted in AI Foundry or running locally, right, to any of your MCP servers. So if you're trying to understand what I've just done, I've I've been able to extend the functionality of this application, this AI application, by allowing this AI application to have access to this MCP weather server. what I did is that I've given this application the ability to give me weather reports. So just as I've been able to do this, you can as well do the same thing. You can host all of your applications and then extend the functionality of your applications by connecting them to various MCP servers. So it could be an MCP server to give you what is the currency exchange, what is the weather report, just like in our case, what is happening in what country of your choice. Any MCP server of your choice, you can then connect it this way and be able to interact with that MCP server right from your agent itself or right from your application. Right? So these are some of the ways you can practically implement some of this. So I'm going to be pausing here for now because I know I've demonstrated a lot, I've shared a lot. Now it's question time. Ask me questions. What questions do you think you are concerned about regarding this presentation? Are you confused about any area you think you need me to shed more light on? I'm here. So let me know and let me see how I can, better clear your understanding on practical implementations of FCP servers. Are there any questions that are being asked? So I know my time is far gone, right? But um, if no questions are being asked, I have one more practical implementation. Is it okay for me to go ahead, Dami, or is my time totally exhausted?
I think that you have a few minutes, say 3 minutes thereabouts.
All right. Okay, good.
Say an hour, 1 hour session.
Okay, good. Now, in these 3 minutes, what I want to explain to you now is how can you expose your API endpoint as MCP tools in an MCP server? How can you expose your API endpoint, right, through an MCP server? So, in this scenario, let's look at this. Here, if you come to this, um, if you come to this AI gateway, right, I've been able to add an API endpoint to this, right? So this is my API endpoint. I was able to do this. You can see, and I exposed certain amount of tools, about 2 tools, right? So I exposed these 2 tools, right, to my. So look at this as an API that has several endpoints, right? I exposed 2 of the endpoints in the API, or let me say 2 of the functions tools of that API as MCP tools through an MCP server. Now, let's interact with that MCP server and let's see how this works, right? So this is basically um, a post and get scenario. Those are the 2 tools from the API that are exposed, and this is the MCP server here calling the what will I call it? This is the MCP server calling the tools, right? So you can see here. Here is the MCP server itself, right? So now let me show you how we can be able to interact with the system. Just one moment. Good. So to be able to interact with this system, we will do it just the same way we've been interacting with every other system, right? Like I mentioned to you, this is a system, is an API endpoint. We have exposed just 2 tools out of that API endpoint. Now we'll come here and we'll open a new terminal. Let me make this bigger. The first thing I'll need to do here is just to source as I would always do. .zhsrc. Good. So I've done the sourcing. Now for us to expose or interact with the API server through with the API through the MCP server, let's go to the environment where we are hosting that. And that directory is here. So we are going to run this locally. We cd to the directory, right? I believe you are able to see my screen. We cd to the directory. Once we cd to the directory, the next thing we do as usual is to build a virtual environment. So I say uv venv. So it tells me an existing environment is there. I'll say yes, replace it and create a new one. Once I replace and create a new, I then activate that environment. Right? Then the next thing I would do is what? I'm going to sync. That's all the packages that need to ensure that this environment runs. I'm going to sync them. So I just say uv sync. Now, all of the application needed has been installed. These are all the packages needed to run this application. Right? So now I'll then proceed to what? Run the application here. Now, for me to run the application, I'm just going to be running this file. Now, with it, right, I'm going to be connecting to that what? API through the MCP server, right? And with that, I should be able to interact with that API easily. So now the environment is being set up. Let's watch and see how this happens. So it's trying to set up the environment itself. So it would probably take some time. It's making all the function calls it needs to make, So you can see now it's setting up the environment. Good. So look at this. It's been able to call the MCP server here, which is if you remember, I showed you here the MCP server. If you look at the MCP server, this is the URL, right? So if you look at this, it was able to call that MCP server, and this is also interacting with this MCP server through an agent, right? It's interacting with this MCP server through an agent. So look at it as I created an AI application and extended the AI application to have access to this MCP server. So now I can now ask it various questions. And in this particular one, this is a pet store that has various pets in it. And I can then ask question and say, what pets are available in the store? So you can see once I make that post, it then tries to interact with the MCP server. And you can see here, it makes all those calls. And it says the pet store currently has a variety of available pets, including this. So it says dogs, cats, other animals. There are also other animals as a princess or a monkey galley. So I can now specify the particular breed I want, right? I can say, tell me more about the dogs, or
Mr.
let's
Promise, yeah, understand.
okay, let me run this last prompt and then I will conclude, right? So I can now say, give me more info about let me say the true who had or let me say the golden retriever. The golden retriever. Those of you who are familiar with dogs, you know that golden retriever is one of the, yeah, one of the species of dogs, right? Now you can see all of this, right? So this is it was able to interact with the MCP server, and it gave me various pictures of what each of the golden retrievers. So if I want to see a picture of the golden retriever Charlie, I just need to come here. I click on the link it has given me, and then I come here and paste that link. So, okay, it looks like the host is down. Let me look for a photo of Greta. So the dog called Greta. Now, look at what he has. This is what he gave me for Greta. So there are various other ones it has given, right? One is called Bailey. Let me see Bailey. Okay, so this one doesn't exist. So anyway, what I've just showed you is or are the ways which you can use to interact with your server, right? That's what I have just shown you. So I don't know if there are any questions regarding this. It's a whole lot of practical implementations that you can do with MCP servers. You know, just generally extending the functionality of your agent applications to be able to get more details or more functions or more inquiries you want to do. So these are some of the ways which you can use to extend the functionality of your applications. And if you have any more questions, you can also drop them in the chat, and you can also reach me out on LinkedIn. At this point in time, I want to thank you, my moderators, my moderator, our
Mr.
leader,
Promise.
Lola Aremu, for hosting me on this wonderful session. And I think I'll be handing over to the next session coming up.
All right. Thank you everyone for joining the session. Please still wait. We have another session or more sessions for you.
Yes, we have more sessions coming up. Yes, yes,
All right.
yes. All right. Thank you very much, all. I'll be handing over the next session now.
While we wait for the next session, if you have any questions, please feel free to drop it in the chat.
Hi everyone. Thank you so much for joining us so far into this sessions. So it has been an amazing sessions with promise on practical implementation of FCP servers. Now we'll be going into another wonderful session by one of our MVP as well, which is MCP security, a comprehensive protections for AI system. So the person that will be delivering this session is no other person than one of our leaders, Rafael Gamomo. Is actually a skilled DevOps and cloud engineer with a strong foundation in Node.js and Python, and he has delivered scalable, secure, and high availability solutions using open source tools like the GitHub, Docker, Kubernetes. Currently, he specializes in FinOps, which is the data-driven side of cloud computing. It focuses on cloud billing optimization and cost efficiency. And recently, I think Ralph just released a book on around FinOps, how to pass the FinOps exams. So it pioneers an end-to-end automation solutions on Microsoft Azure, implementing infrastructure as a code for resilience development across web applications, Kubernetes workload. His work with Azure cost management and billing tool has led to 20% reduction in monthly cloud spend, which is achieved through close collaboration with both the finance and engineering team. Mr. Raphael, are you with us today? Good to have you today with us. Mr. Raphael, are you there? Let's give it a second. Yeah, can you join the stage? So let's wait for Mr. Rafa to join us shortly. All right, good to have you, Mr. Raphael. Yeah.
I'm so sorry. I just realized that I turned off my camera. That's why you guys couldn't see me. But I've been here all along. Good
That's
afternoon. I'm excited to be a part of this. And yeah, so it's been an exciting journey. Emmanuel, thank you for the introduction. You said a lot. And I'm sure that we're going to have a nice day. So I'm going to share my screen and just proceed with the session. Emmanuel himself is an MVP. Thank you, Emmanuel. I appreciate you for the introduction. Just give me a minute. I'll pull my slide. So today, what I'm going to be doing is I'm going to be introducing uh, MCP security. I'm going to be introducing MCP security, and also, guys, I want to thank all of you. Thank you, Damilola. Thank you, Kristen. Yes, it shows that you guys are. Yeah, it shows that you guys are good people. I mean, you care about me. So yeah. So I'm going to be sharing my screen. So today I'm going to be talking about MCP security, because the way it is, the way we used to do things before, because of AI agents, the 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 narrative has shifted a little bit. Okay, so there are new actors, and we have to do things accordingly. So I'm going to be doing the theoretical part, and I'm going to be opening my VS Code and uh, show us this in practice. So give me a few minutes, just in case the name on the slide. Let me quickly just edit it in case there are new people that don't know me. They will see. I hope you can see my slide now. Okay, I think I've edited it. My slide is still not coming up. I'm so sorry. Okay, yeah, you can see my slide now. Okay, ladies and gentlemen, welcome to my session. Why does this session matter? Okay, things are different. This is not 2024. This is not 2023. This is 2025. As you all know, things you can build applications using AI agents. There are vibe coding tools. I can put my prompt into, and they will build my applications for me using AI agents. And because of this, new types of attacks are in the domain. Okay, so the ease at which we do things has exposed us to different and new types of attacks. Now, secure by design it's what Azure has been Azure has been emphasizing all along. When we got into this field, they will tell you that everything is in layers, everything is secured, everything is like an onions, security is in layers. But because of that, Azure has also taken it upon themselves to make sure that these new things, we should be aware and know how to uh, take take the necessary action. So consider AI as you can see from my screen, consider AI as a sophisticated bank vault that is capable of answering your questions. Now, in the traditional system, you'll have lock and keys and all that, but with AI, you just need to say the word or put the prompts and things get done. So this is why the subject around this discussion has become important, and we cannot leave it just like that. Now let's take a look at the different types of attacks in 2025 that the evolving AI that we are looking at has exposed us to. One of them is prompt injection. Okay, so manipulating an AI behavior, it's all about when you manipulate an AI behavior by crafting malicious input or embedding hidden instruction. Okay, so an example is you can fake instructions within an innocent document that an AI is asked to summarize. That is actually very, very easy to do. Okay, so and because of this, and that's easy to do. And I think in my demo later, I will be showing you how to make sure that this one of the ways we can avert this. Another thing that our almighty AI has exposed us to is tool poisoning. Okay, compromising an external tool, an API that agents rely on. Okay, and yeah, so you're all seeing all of them in the screen. And yeah, so from session hijacking to token pass through to giving something an excessive permission, all through to supply chain risk. I'm going to be moving on to the next slide. Now you all know that when we started this field, we know that the first thing to do when security is authentication and authorization. Just give me a minute, guys. Give me a minute. Okay, sorry for that little disruption. I'm just going to continue. Um, I'm just going to go back to my slide and continue. Just give me a minute. Okay, so as you all know, the things that we know, the first line of defense, the things security, they are still the same. They have not changed. Okay, so when you all that are listening to me, you join this line, which we all have common interests, which is why we are all here. So we knew that when you're talking about security, you look at authentication and authorization. Okay, so you give zero trust to everyone. No one is supposed to be trusted unless they are verified. And Microsoft has a robust system for us to be able to do that. We use Microsoft Entra ID, and for that, and for this, for with AI system, we make sure that we validate and we also use principle of least privilege. So those principles that we know, they have not changed. Okay, so they have not changed. They still remain the same. It's just that with AI agents in the surface, we need to take extra caution. Okay, so you take tokens. You make sure that everything is token based, and you take tokens. Tokens are like key cards that grant access. So the key cards must be valid for a specific door. So you use tokens for agents to be able to get access to whatever they are trying to work on. So you don't just let them through like that. Okay, so yes, so we'll take a look at another side of things. Now, everything I'm speaking is actually taken from the official materials, official repo that Microsoft has provided for this. Okay, so yeah, I've just condensed it to make you, just condensed it to make, to just follow through. Okay, just give me a minute. Okay, so we have the prompt sheets, we have GitHub Advanced Security, and we have safety. So those are the provisions that have been made by Microsoft for us to be able to stay and withstand anything that is happening in this era with regards to AI. So prompt sheets detect and utilizes malicious prompt, and yeah, malicious prompt, preventing the attackers from manipulating the AI behavior. So you should make sure that you're well shielded, and also you should also make sure that whenever you use you're using content, you always make sure that that's safety. You have the filters, you have everything to make sure that you are safe. Okay, and if it's something to CI/CD, you use enough tools, you use all the tools that have been made available to you. One of them is GitHub Advanced Security. They secure the underlying AI system. They identify vulnerabilities and secrets, and make sure that dependencies are taken as dependencies, so that you don't do the unthinkable. Okay, so let's take another look at the whole thing. Okay, how do you secure the foundation? Because AI, the foundational things are the most important ones. So how do we secure the foundation? We also, first thing we need to do is that we need to make sure that every API, every model that we are working at needs actually to go through rigors of verification. We need to check them out. You need to make sure that they can be trusted. Okay, so yeah, they can be trusted. Now, um, as someone that's into DevOps, we all know that you don't just push into CI/CD, and we don't just push a code to CI/CD and just let it go to production. They have to be different stages. So the things that you are used to already, it's highly, in the era of AI, it's highly recommended that you do not break any part. So it has to go through the development stage. It has to go through the scanning stage. It has to go through the staging environment where you simulate real life scenario of you have to go through the staging environment where you can do your all the necessary testing. Go through the real life. You hit it hard with everything before you push it into production. Okay, so we have the OWASP top 10 and LLM guidelines. We are, whatever we do, we make sure that we don't skip anything. So the truth about all this is that when you're looking at AI and security, the things that we know, the principles that we follow, you do not break anyone. You really follow through. Okay, we follow through every. You don't compromise any process. So that's just the main thing. So these, as a DevOps and a cloud engineer, these are the things that we've all been used to. So we follow through with all of them, because they will always make sure that our whatever we are building, it's safe. Okay, because like I said at the beginning, the fact that AI has made it easy to build application has also made it easy for bad actors to do whatever they need to do. Now I want to tell you that being in this space that we are all in, I think that even, I mean, this is my own view anyways, I think that in the next 5 years, people might not even be coding anymore, because AI agents will do all the jobs for you. So and if it's that easy, it's also very easy to break the applications. And when we get to that, all the things that we know even before this part, we need to put them in place. Okay, we need to follow through with all of them. So from verification to integrity checks to using the necessary tool, and also enforcing zero trust for monitoring. Okay, so like I said at the beginning, as we all know, Microsoft has been advocating zero trust right from the beginning. Okay, so security is a layered approach. Okay, when we say security is a layered approach, defense of the data center can be a layer. The physical security guards that are there can be a layer. Okay, so the network applications and the things that have been put in place that you need to check into to verify yourself before you go in, it's another layer. The application itself has some things that you need to that has some things that you need to authenticate into before you use. So security has always been a layered thing. So, and Microsoft, in this era of AI, Microsoft has also said that we should make sure that we employ multiple layers of control in order to protect ourselves. So we're going back to, like I said, we're going back to all the things we know before. Security has to be, has to always be a defense in-depth thing. Okay, so the passwords are not enough. You need to do multi-factor, and you need to do multi-factor, and so all of them, okay, will save us from malicious bad actors. Okay, so AI controls prompt injection defense and content safety filters. Let's move on to the next one. Okay, so I think at this point I will switch over to my VS Code. I want to give a simple demo to. I'm gonna give a simple demo to tell us one of the ways we can defend ourselves in this era of AI, and how MCP servers can help us with this. Just give me a minute. I'm going to be switching from my slide to VS. I'm going to sharing this so that I'll share my entire screen if possible. Stop sharing this. So I've actually created with the demo that I'm going to be working on for you. So I've created a client application and an MCP server application for us to be able to do this. Now, everything I've said so far, I have said from the official material that Microsoft has provided, and I'm going to be making it available in the chat. Let me see if I can get the chat. So here is the chat. Okay, here is the chat. I've sent the official material Microsoft has provided. So my slide is actually not too different from whatever is in the chat. It is in that material. So my slide was made from that material. Just give me a minute. I'm going to be sharing my repo. Okay, so I'm going to post my repo in the chat as well, because I don't know if I'll be able to share it directly. Just give me a minute. Okay, so give me a minute. I'm going to share my repo in the chat. And after that, I'm going to share my screen. Okay, we're going to do a typical simulation on how to keep safe in this era of AI. Okay, with regards to security and MCP servers. Okay, so I've shared the document. Give me a minute. I'm going to share I'm going to open a new folder in VS Code. I'm going to call it MCP D for demo. Just give me a minute. I'll be with you soon. Okay, so I've just give me a minute. Okay, so now I'm sharing my, oops, sorry for that. Yeah, sharing my, no, oh, sorry. I'm sharing VS Code. It's coming up, just give me a minute. I can't see the tab. Okay, so for some reason I'm not seeing. Okay, I can see it now. So I'm sharing VS Code. I'm just open terminal. Okay, so I'll just open terminal. I believe you can see my screen now. Okay, so I believe you can see my screen. So I've shared the repo with you. Okay, so I'm building a simple project that would explain how MCP servers work. Okay, so one of the ways that we can keep ourselves secure in this era of AI is to always make sure that we validate user input safely. Okay, so this demo also will signify how to run a server with STDIO transport, how to use inbuilt MCP clients to call tools, and how secure by default validation prevent abuse. Okay, so I like the fact that Microsoft. So I like the fact that Microsoft is doing everything to make sure that people are safe and nothing goes wrong, nobody gets into trouble. The way it's so easy to build application now, guys. Trust me, it's so easy to build applications in 2025. So the level of threat has increased. So everything that we are saying here today, it's should be taken seriously. I think from the little conversations that I've had with you so far, so from the little conversations that I've had with you so far, is that number, because I'm going to be asking questions later on. All I said, okay. So before I start the demo, I just want to, okay. So number one, because of how easy it is, how AI is, okay. So there are different kind of attacks. The first one is prompt injection. Now, these things I'm saying are from the repo, official Microsoft MCP repo I shared in the link with you. So we have prompt injections, okay? We have tool poisoning, okay? So they can poison your tool and modify the API that the agent is using, okay, for malicious purpose. They can hijack your session, okay? Hijacking session means that, an attacker tricks the AI into doing something on behalf of the attacker instead of you. Token pass through. Okay, if for token pass through, an attacker can capture a token and use it to access what he does not have permission to access. Okay, then we have excessive permission. Now you know that for this field that we are in, you only give someone the permission that he needs to do the job that he wants to do, and when he's no longer supposed to be there, his session is supposed to expire. That is how it's supposed to be for compliance purposes and for best practices. Okay, so but you can use because of this these AI things, okay, they can actually make the AI agent to get excessive permission. Now, for the final one is supply chain risk. Ladies and gentlemen, I'm going to, at the end of the session, I'm going to be asking you some few questions. That's why I have to repeat that again. So I just want to do the demo to reinforce the points, okay, to reinforce the point before we look at the remaining slides and close the session. So give me a minute. I think I have, I was sharing my screen. Okay, so I think my VS Code is ready for demo. Okay, my VS Code is ready, and you have the repo. So I'm just going to be following through with what I've prepared in the repo. Now, why MCP security matters? Now MCP lets developer, now model context protocol let developer expose tools to LLMs safely. Okay, so yes, as you all know, you know what MCP is. Promise has made a very good introduction of it. Yeah, so Microsoft has done all its best so that whenever you are doing anything, it expose your tools get the right exposure without getting without getting into trouble with all the points I listed earlier on. Okay, so AI models can be tricked, as I said earlier on. So tools must validate every input. Okay, tools must reject suspicious pattern. Okay, so if it's not the right input that tool is expecting, that tool is supposed to reject it. If there's a pattern that is not right, the tool is supposed to reject it as well. So with MCP security, we can actually make sure that only what you're expecting is what is being returned to you. Okay, so one thing I want you to appreciate is that as the development of AI is growing stronger, Microsoft is doing everything to make sure that things we are not compromised. So, and I like that. Okay, so and this little demo centers and borders around those facts and concepts. Okay, so the project structure of what we are doing. So we're going to be building a server. Okay, we're going to be building also a client. Okay, we have the requirements and that's what, as you can see from here, I did everything, and with the README that you're looking at, virtually demoed it before the session. So I'm trying to work on it again. So hopefully everything goes right. So now the first thing we do, as you all know, is to create a directory, or well, we're going to create a directory and we're going to cd into it. Okay, so I'm going to just type this in my terminal. So we have created and we have cd'd into it, and as you can see, we have the folder on the left hand side. Okay, so the next thing we are going to do is to make sure that we use a virtual environment. Okay, a virtual environment makes sure that everything that we are doing is isolated. Okay, so that the global system is not affected. This is actually a best practice even for your other projects. Okay, so when you're working on a project, make sure that you isolate it from whichever other things that you're doing, so that everything does not mess up everything. Okay, so that's the simplest way to say it. So I'm going to create the virtual environment and activate it by sourcing. Okay, so as you can see, we have okay, so it's coming up. I believe that is going to we're done with that part. Okay, so the next thing is we're going to create the requirement.text. Okay, we're going to create a requirement.text. That is not too difficult to do. Touch is the command you use to create a text file. We're just going to say touch requirement.text, and we'll put all the things that we need to put inside it, and we should be fine. Okay, so mind you, you can also create it from here. If I click here, but I prefer to do it from the terminal touch. Okay, so as you can see, we have our requirement of text here already. I'm going to put the content of it. Okay, I'm going to go back here. I'm going to drop in the content, and we are good to go. Okay, so the content is there as well. So the next thing we're going to do, we're going to install, okay, by running pip install. Now, I want you to know that if you're going to be doing this demo, you need to install Python. Okay, you need to install pip. Okay, if you don't know how to do this, okay, I think that Microsoft is amazing. You can just click on the chat here and open chat, and the AI agent will do everything for you. How easy is that? Okay, so make sure that you are in agent mode, not plan, ask, or edit. Okay, so the AI agent can install everything for you just in case you are struggling with that. Okay, but I have Python on my computer and I have pip installed. So so the next thing to do would be to install the requirements. I'm going to hit enter. And as you can see, we have done that, or we are currently at, so we are okay. Okay, so we have gone. So, okay, so we are. Excuse me. Okay, so at this point, we need to create the MCP secure server, the server.py. Okay, so I'm just going to type touch server.py in my terminal. Oh, okay, still loading. I wasn't looking. So you need to let this finish first. Um, Okay, so that's fine. It has installed everything. I'm just going to clear so that we have more space. So I can just say touch server.py. Okay, if I hit enter, okay, so you can see that it has created the server for us. The server, so we're just going to put the content which you have access to the code. You can just play around with it uh, and and demo this along. I'm going to put the content of server.py in the file. As you can see, we have no error. Everything is good. So now, why is this? Okay, now the file exposes an MCP tool. Okay, so there's a tool in the code that is called greet. Okay, so this file exposes an MCP tool. It validates the name. Okay, the name and demonstrates safe error handling. Okay, so we are working around this file and to make sure that the principles of MPP security are shown to you. Okay, so why does this matter? Why is this file important? Now, it will make sure that no one injects anything into our code. No one does prompt injection as well. Okay, no one can script tag. No one can do SQL like payloads or do anything that would harm what we're expecting. Okay, so it's only what we're expecting that we will see. Okay, so no one is hijacking your code. No one is, it's what you're expecting that that you will see. Okay, so which is a good thing. Okay, which is a good thing. So just give me a minute. I think that we should. We're going to create the client now. I've created the server. We're going to create the client now, and we should be good to go. It should be good to test, not good to go, good to test. Okay, so uh, touch, okay, client.py, okay, client.py, and I'm going to drop the file for the client. I just want to confirm again, okay. So the file for the client, oops, sorry. So we are good to go. There's no error from our client. There's no error from our server. So we can just run the demo. Okay. So what are we expecting to see? The message I want to see is my name, Raphael. Okay. So yeah, if I'm going to see any bad thing, it will tell me invalid name or only letter. So this is what I'm expecting to see, and this is the only thing that I should see. Okay, so and just give me a minute. So I'm going to test it. Okay, I'm going to test it. So okay. Oops. What happened here? Okay, so I built this earlier on, and okay, so I'm gonna put this in. Okay, so I don't know why that error is showing. I built this earlier on and I tested it robustly before the session and it worked. So I don't know why it's showing me error in this one. Okay, just give me a minute. Okay. Okay, so hold on, just give me a minute. Okay. Okay, so I'm having some errors. I'm going to stop it. Um, I tested this earlier on before class and it worked well. It showed only what I was expecting to see. Okay, so I don't know why it's giving me little errors. Okay, but the importance of this demo is that just give me a minute. I'll continue sharing my slide and I will what I'm expecting to see and what is expected. Okay, so this the importance of this demo with regards to MCP security is that, like I said earlier on, only what I'm expecting to see is what should show. Okay, so bad inputs get rejected, and it should be good, easy to modify. So anyone you have the files with you, anyone can modify it, and yeah, anyone can build on this. Okay, so it's actually the reason I chose it is because it's an easy demo, but I don't know why it gave me those errors. But I'm going to leave that. I'm going to continue so as to finish my slide because I see that the time is running fast. But I tested this before class and it worked well. Just give me a minute. I'm going to switch back to my slide and finish what I was trying um, to to pass across to us. Okay, so I think that we've looked at this. Okay, so we've looked at this. I'm just going to move it. Okay, so we switched to that demo because we were here. Okay, so a malicious actor can bring a prompt. So the AI assistants get tricked and boom, before you know it, it gets into the API keys. Okay, so we don't want that to happen. So with MCP servers, you can prevent a lot of those things. Okay, so yeah, like I also like a picture paints 1,000 words. Okay, and yeah, we don't want any of that to happen. So MCP servers have the security protocols to make sure that any of these do not happen. Okay, I think okay. So now we're going to be talking about JW tokens. Okay, so they are a compact URL safe means of representing claims to be transferred between two parties. So I was actually choosing to do a demo of this. This is in the official notes that I sent to you. And so the way they are is that when you use them, the tokens actually should expire to prevent reuse or replay. So that it is one way of making sure that bad actors do not get into our workload. So when you use the tokens, yeah, when they are used once, they expire. So they are good. It's a good practice. I think we've talked about this. This is just least privilege. You give only what people need for what they need to do. Okay, so that principle still stands even in the era of AI. It does not change. Okay, so don't give someone excessive permission. Okay, if that person does not need the authorization to use keywords, don't give him. Don't grant him the authorization. Okay, so people should be given, or people or systems should be given the most minimal permissions to do what they need to do. Tokens should expire, or sessions should expire after the time. So like giving a janitor, I'll use AI agent to represent the janitor, a master key to the entire building when they only need to clean the closet, maybe for 1 hour. So least privilege is a good principle, and even with AI, it has not changed. And what are some of benefits for using all this? So they prevent unauthorized action and unauthorized AI access. Okay, they limit potential impact of security breach. They reduce attack surfaces by minimizing exposed capabilities. Okay, so secure session management. Okay, so secure sessions in action. For a secure session, for a secure session, there's strict timeout. You limit the window of opportunity for attacker. So if the time is very narrow to the time a person needs, like for example, if I'm working on a project and it's for 40 minutes, and yeah, it's for 40 minutes, it should be for 40 minutes. Okay, so when the timeout is strict, if it's for 2 hours, 2 hours, everything should expire. It makes it difficult for an attacker to just come and do anything. So enforce HTTPS, so that you make sure that all sessions are encrypted. If the session is not secure, no one can get access to it. Okay, so random unpredictable session ID would prevent yeah. So we should also make sure that the IDs that we are using are not the same. Okay, so you randomize them at every point in time, so that brute force, this would actually prevent brute force or guessing attack. Okay, so no one can guess your ID and all that and all that. So I believe that uh, these are things that we know even before the advent of AI, and with AI and MCP still enforcing all these practices that we know before. Okay, so another thing that we should take a look at is monitoring and response. I believe that this should be the last or second to the last slide. Microsoft Defender for Cloud is there for us. Okay, if you look at Microsoft Defender for Cloud, there's Defender for everything. There's Defender for virtual machine. There's Defender for network. There's Defender for literally anything. So you should make sure that you use them robustly. Okay, use Sentinel, SIEM, the ones that have been provided, or the cloud native ones. This will make sure that we can monitor everything that we are doing. When there's an attack, we can detect it and we can respond within we can respond very fast. So another thing we should take note of is governance. I think might just give me a minute. Okay, so I thought I received okay, so just give me a minute. I think we are almost done. I have 6 minutes left, but I should be able to finish before the 6 minutes. Give me a minute. Okay, so my slide is I'm looking at, just give me a minute, guys. Oops, sorry. Okay, so governance and compliance, as we see, we should always follow through with the governance and compliance practices that our organizations are following. Okay, so you can't escape. So I believe that if we adhere to the governance and compliance practices that our company is following, we will not fall into any drama with bad agents. Okay. The last one, okay, pin dependencies, signed package. We'll make sure that our packages are signed. Okay, we'll make sure that we use GitHub secrets for whatever that we are doing, and don't expose your secret in the repo. So the best practices for all this, we know that never save sensitive things inside code. Use key vault, use all the cloud native ones. Yeah, so if we do that, I think that no one would be able to secure our workload, and there will be no issues. Okay, securing AI supply chain is fundamental to prevent vulnerability at any stage. So whichever the stage, whether it's the development or production, you follow through with all the practices, you'll be fine. Okay. Okay, so we are back to this. Because of time, I'll just go to this. So the takeaway from this session is that the things we know before, they've not gone away. Okay, the things we know before AI came, they've not gone away. The foundational knowledge of security that we are aware of, they are still there. We hold on tight to them. Then we follow through with AI threat mitigation. We use governance. Okay, like our zero trust, we verify everything. Defense security has always been layered. We follow through with that. Then automation and visibility, we should follow through with that as well. So I want to ask a few questions if you were listening. So what is prompt injection? So we have a few questions, and I think I have the answer. What is prompt injection? Prompt injection is just manipulating an AI behavior by crafting malicious input. Let me see if someone in the chat is answering. No one answered in the chat, but that's fine. How does token pass through create risk? Now, token pass through is an unvalidated token, okay? Forwarding token without proper authorization and usual verification, okay? And I think zero trust, like we all know, has been the thing that Microsoft has been advocating right from the beginning. Even in MCP security, all the things that they've been advocating since the beginning, they are all still there, and we need to follow through with all of them. Now, thank you very much for listening to me. Security is a design principle and not a patchwork. Thank you for listening. I hope that you've been able to gain one thing or two from the session. Please ask me any question if you have any, and I'll be willing to answer it. Okay, so there's no question. Emmanuel, I'm cool with my session. I'll hand it over to you.
That's a very powerful session, Raphael. It's actually a very insightful session. Learned a lot about things we need to do around securing the MCP servers. Thank you so much. So I think we have another session that will be handled by Manuel Ako. I don't know if he's online.
Yes.
All right, Christian.
Thank you very much, Emmanuel. Yeah. So, firstly, I would like to thank Rafael for actually discussing the importance of implementing MCP security and for highlighting the principles of defensive debt. I actually learned a lot, and I would like to say thank you once more. Yeah. So, I will be introducing the next speaker in the person of Emmanuel Ako. It's a cloud and DevOps engineer and a technical writer. So I would urge us to pay keen attention to him as he walks us through the best practices for developing MCP. Thank you very much, Emmanuel, and you can take it from here.
Okay. Good afternoon, everyone. We started our session today, which is season of AI. That's from everything around MCP. So yeah, Kristen. Hello, Kristen.
Yes, I'm here.
My slides is in the presentation. Can you help me bring it up?
I do not think I'm the one responsible for that.
Okay, it's up. It's up.
Okay, thank you.
Okay, yeah. So yeah, so today I'll be walking you through our today's topic, which is MCP development best practices. So this is based on Microsoft's MCP for beginners curriculum, specifically the best practices we have there using Microsoft's AI Foundry. So my goal for this session is to make everything practical, simple, and actionable, so that you can start applying these ideas immediately. So yeah, our session agenda for today, we have quite a number of them. So our first one is what is MCP and why best practices matter. We'll look at that. Then also, we're going to look at core principles of MCP development. Then we'll look at prompt-driven development approach. Then after that, we'll look at security best practices for MCPs. As though Raphael has touched much on security, everything on security, we're still going to look at security more. So, and modular architecture, how we break our architectures into modules rather than building our MCP in a monolithic architecture type. Then also testing and validation and robustness of our MCP. Then development and operational consideration. Yeah, we don't want to build MCP in our machine. Oh, it's working on my laptop, or when I deploy it to the cloud, it's not working. We'll look at that then. We'll also look at the summary and recommendation for that. All right, so let's get started. So yeah, MCP is a thing that has been out for a while. We all know MCP is model context protocol. MCP is basically um, how MCP connects LLMs, that's large language models or agents, to to talk to external systems like tools, APIs, and data sources. Then, so we should think about MCP like a standard, like a language which this system use, because MCP is widely being adopted. So following the best practices is crucial. So it enables your servers secure, reliable, and maintainable and scalable as you go in the long term. So building MCP is not just a now thing. You have to think for at least for a long period of time, because I mean, um, usage and that and stuff like that. So what are these core principles of MCP? So these are engineering principles, but in MCP itself, they matter more than just because the consumers are not humans. The consumers are large language models, that's LLMs. So these models rely on clarity and consistency. So um inter, when your interfaces are predictable and well structured, the agent performs better and reduce fewer errors, and also become easier to integrate with. So things we need to consider, core principles we need to consider when developing our MCP is simplicity over complexity. Yeah, we just build something simple. Over engineering or building something complex doesn't work. Yeah, so clean and predictable interfaces. Yeah, so your make sure that your user interface and your user experience are key, because these are key things, because your consumer here are not humans, they are the um, agents, and when the agent is being bombarded by a whole lot of different things, they start hallucinating and underperforming. So separation of concerns is also something key. Then consistent naming and structure. Yeah. Also, if you are following the major software development life cycle, like from staging environment, um, so from dev environment to staging environment to production, you have to ensure that each tool, each service you are working with all has a consistent naming and structure. Then also documentation matters, as well as you are the one building it. Tomorrow might not be the one also interfacing with it. There are a lot of users out there that are going to use it, and documentation matters for your code base. Even when you're writing code, you're advised to write a README, you're advised to comment here and there, so anybody can come and read it or come and understand. And also, um, on the long term, that is good. So, like I said, long term maintainability is also key thing here. So, let's move to the next slide. So, prompt driven development approach. So, I mean, a lot of us use Gemini, ChatGPT, Claude, Perplexity, and the like, a lot of LLMs out there. But one thing we need to know is how we prompt these things and how they give us um, replies. So this is a unique mindset shift, if I may say, the prompt driven development approach. So instead of you building APIs first and you say, okay, my model is going to figure them out, and you design with prompts in your mind. So you have to ask yourself questions like, what would a model naturally request? Then you structure your functions, schemas around that. Then this helps you improve your accuracy and reliability. So first thing first, you have to design APIs around likely prompt patterns. You know how we humans think, so you match keywords and all other approaches. If people okay, if certain keywords are in place, what's this person trying to talk about? What person trying to prompt about? So those are kind of things you have to do. Then also you have to think like, oh, how would an LLM ask for this? How would an LLM retrieve data from data sources, from tools, from APIs, from all over the internet, from search engines? So we have to listen. So also we have to reduce ambiguity. So like I said, building something very complex and robust. No, putting something robust for long term is good, but when you are just your initial design is being complex, it makes your LLM misbehave and bring in some unwanted data and information to you as a user. So also you have to provide explicit input and output schema. This is very important when designing out your architecture. So like I said, predictable behavior is also equal to better AI performance. So security best practices for MCP servers. So like I said, Raphael has touched more about the security aspects, but I feel security is still things that are underrated. Almost every week, companies and applications, softwares are being tampered with, are being hacked into. Yes, so security security threat is a first class concern. Like I do tell people, it's not an afterthought. It's not a patch, or it's not something that, okay, once I design my MCP, I will still come back to security. No, as you are developing, as you're moving to staging, as you're moving to prod, you are all testing, you are checking for each vulnerability. A hacker can um, can see and penetrate into your system. So, like I said, security is non-negotiable, and since MCP servers can expose high privilege functions and user identities, you must ensure that they can't be misused, whether intentionally or accidentally. These are things we need to put in mind. So, simple things like input sanitation and let's say safe error output, proper logging, and rate limiting go a long way in helping you to harden your MCP servers. So there are a lot of these things. If you go from the identity and access management, giving the rights authentication and authorization where needed. Those are key things. Using principle of least privilege. Who assess this? You don't give users more than what they require and less than what they require. Also, so also zero trust. You can put zero trust in place system. So at least you don't store your sensitive key in your environment file you use. So if you are using a version control, you can use the environment variables and secrets over there. Or if you are building directly on the cloud, you can use secret management tools like Azure Key Vault and the likes also. So yeah, you can also add safe error messages to do this. And yeah, your log analytics has to be proper. So if there's any abnormal detection, you can connect it to your Microsoft Sentinel or Azure Monitor or log analytics, something that gives you notification whenever there's any anomalies, anything that's beyond the regular happen in your MCP server or your environment. Just report it and flags it out as um, there's maybe a threat actor or something that's happening with your MCP servers. So let's move to the next slide. So yeah, modular architecture. So like modular architecture is like I won't say the main thing behind your MCP. Whether you're building any kind of application, software application as it may concern, this is um, on rare occasions, except if you're building things that you know that a lot of users, thousands of users, hundreds and millions of users are going to access, you avoid building a very large monolithic MCP server. Yeah. So instead of building one huge MCP server that does everything, it's better to break it into different modules and layers. Like I gave there, using building blocks like functions, you can put maybe one module will be for function, another for services, another API managers and abstraction layer. Because this makes everything to have like a clear boundary, and this makes the code base easier to maintain and reduce the whole cognitive load. So you also get flexibility. If one component changes, you don't have to break the whole system. And even if you're having an error to troubleshoot that you can easily spot, okay, this is where the error is coming from. But just having let's say 50,000 line of code inside just one monolithic code base, that is disaster. So benefits and why this modular architecture works for us. So it enables us to be able to reuse our code base, yeah, and it's easier to update if we want to roll out versions and updates. It's easier to, oh, okay, I just need to change this maybe in the function, maybe this in the services, this in the API manager or in the abstraction layer. Then also another important reason is scaling for specific components, and also it reduces complexity, like I said. So yeah, testing validation and robustness. So MCP, so testing for MCP servers beyond just traditional unit testing that we do, UAT and integration testing and all of testing. So you need to also test how these modules interpret your responses. So sometimes the functions works perfectly, but the model can misinterpret the structure. So testing those interaction early prevents confusion and build trust in how this server behaves with each data sources it's interacting with. So, like I said, you also like you do for your normal software application, MCP is no different. So you write unit tests for the MCP functions, you test edge cases and invalid inputs. Then keyword testing are also there. You ensure graceful error handling, you validate schema, and you test how LLMs interpret outputs. And if I must say, MCP is really, it's not just a one-time build and you figure it out. Like if you look back at November 2022 when OpenAI wrote the first version of ChatGPT, we saw because sometimes I try to look back and look at how ChatGPT works and the improvement it has the OpenAI team have been able to do over the years and how far ChatGPT has come over this let's say 3 years now. It's beyond grateful, and I see like almost every week they're rolling out updates, whatever deployment strategy they are using. They're rolling out various updates, and it's always like improving because they're also testing because they're doing a lot of testing and validation on each use cases, and also they're also getting user feedback heavily and making sure these things are being in place. So next slide. So deployment and operational consideration. So um, like I said, sometimes we just run code or MCPs, even just in our local machine. And these things are just okay, it works in my local machine, but I deployed it to cloud. My function is not working, my service is not working, the API management is not interacting, this cannot connect to this is not talking to this, like what's happening. So we have to look at some deployment and operational consideration. So once your MCP server is ready, treat it like any other production service once you are deploying to the cloud. So use automated pipelines like CI/CD pipeline for deployment. Also, you have to version it properly. Like I said, like I gave an example there, 0.0.0. So the first zero there is for in a software release, we have this principle that we have like three. So the first zero there is for major, then the second zero is for minor, then the last zero is for patch. So let's say your version one can be 1.0.0. Then if you have any patch to that version one, you just do 1.0.1. Then if you have any minor release, it will be 1.1.1, like that. So also you have to pick a deployment strategy that works for you and works for your users, whether it's blue-green deployment or rolling updates or whatever deployment strategy you do that has a rollback plan, and you can easily revert to if the new updates is not being it's not being effective, and you also don't want downtime also because anything we do in terms of deployment and operations is well as you automate updates where possible. So um like I said, downtime is not a thing or a factor we need to consider, I guess. So downtime or errors that ripple into multiple systems, we'll just have to scrape it, and anything manual, this thing, we'll just have to avoid it in our system and all. So next slide. So summary and recommendations. So what are the things we need to put in mind when developing or best practices to develop MCP in general. So, in summary, MCP development is a blend of good engineering principle and practice, as well as an AI informed design. So, if your MCP server is clear, secure, modular, and well tested, agents will perform significantly better than it will ever be. Then these best practices we just discussed about ensure that your work is future proof, like long term. So even if you are going to build on it, maybe come 3, 4, 5 years later, it also still works on that um, the architecture you've laid down, the foundation you've laid down, the blueprint you've created for all these things. It works easy, so that it will be also easy for you to maintain. Um, Whereas you just make few changes if you want to move thereabout from like versions to version. So also it aligns with Microsoft standards. So another thing we need to also look at is compliance. So with MCP, when developing MCP, compliance is something key. You just have to follow all Microsoft standards and compliance. So yeah, like I said, you have to design with prompts in mind. So if your MCP is just specifically maybe just for a particular software, you just have to build around that. If it's something like general purpose, yeah, it's fine, you can do that. If it's specific, just specific, you can also tailor your prompt to fit around that. So you keep your interfaces simple and predictable. Another thing I said, user interface and user experience are key things. Yeah. So also prioritize security. Like I said, security is not a afterthought. It's something you start even before you develop your architecture and all of that. You have to prioritize security. Also regular testing, monitoring of logs, maintenance every day, because these attackers, these threat actors, they are not sleeping. They are not. They are not stopping. They are always looking for a loophole to enter and uh, to terrorize. So also we have to build modular component. Like I said, building monolithic architectures components when building our MCP is a no, especially if we want to have different building blocks like our services, AI, API managers, functions, and the likes. So those are a no. You have to break it like the way we build microservices in our software development lifecycle. So also test thoroughly. So start from like unit test, UAT test integration. Um, Also in our pipeline, we can also put some kind of tests and checks in our code for code vulnerability, like static code analysis for our code vulnerability for and the likes, all kind of tests we can do down to production environment, all kind of this. And so also, like I said, deploy with confidence. So make sure you keep position things for versioning also. So having versioning you can roll back is key thing. And also monitor, like you can connect maybe whether it's a Slack notification or an email notification, wherever you have a downtime or you are passing a threshold for a particular computer and everything. Maybe you have used more than 80% of that, or threat actors, anything, monitor and get feedback from all. So yeah, this brings us to the end of our session. Um, the MCP development best practices. So this is the end. So and thank you. So if there's any question from any of the audience, I would love to answer. I mean, we have a lot of time, so we can make this interactive as possible. Any question in MCP development best practices? Thank you.
Thank you very much, Emmanuel. I think there are no questions. Yeah, and yeah, thank you for walking us through the best practices for developing MCP model context protocol and for highlighting the core principles of MCP development and touching on prompt driven development and so on. So I'm grateful. So I will be handing over now to the next speaker or moderator. So, hello,
Right.
kindly take it away from here. Thanks.
Thank you so much, Ramosele and Emmanuel. Thank you for that session. And we have gone through 3 sessions already. So if you're just joining or you've been here, you can catch the previous session on MCP, develop best practices, comprehensive protection for AI system, practical implementation of MCP servers. And now, for the last session of the day, we'll be looking at enterprise integration of MCP servers. And to take us in that is Mr. Imor. Mr. Imor is an experienced solution architect, DevOps, and cloud security professional. He specializes in multi-cloud solutions. He's also a Microsoft certified trainer, an MVP, AWS community builder, and also a great leader. And he'll be taking us in this session on integrating your MCP in enterprise context rather with Azure, OpenAI, Microsoft Foundry, things like that. So he's here already, and I think he's just ready to dive in. All right, Sammy.
Thank you, Dami. Thank you very much for having me. Hello, audience. Good morning, good afternoon, wherever you're joining us from. So this is thank you, Dami Lola, for the introduction. Before I move on, I would like to enlighten the audience that this section is actually a part of the global season of AI, focusing on MCP server development, and this is powered and brought to you by the Azure Nigerian community. And you must have seen some of the form for you to fill the feedback form being posted on the chat section. So please do well to fill the survey form. It is to enable us to at least aware of your experience in this section, and also links are being shared for learning materials whereby you can self-develop your skills beyond what is being delivered during this section. So today I'll be speaking on the MCP server integration with Foundry agent and Azure ML pipelines, Azure machine learning pipelines. So this is a section that I've come up with something that I built and I would like to share with us. And at the end of the day, I would like to point you to the GitHub repository where you can get access to all the resources that are being built behind this solution. So it's a simple MCP server that interact with your agent on the Foundry and then help you deploy the ML pipelines to create your workloads and all that. So introduction is that I'm going to be taking you through the introduction. I won't do so much because the previous speakers have said so much about MCP servers, and I believe by now we have a clearer understanding, security best practices to follow and all that. So I also look at the requirement for implementing this solution and also set up steps for this particular solution. And all. Then I take you through the MCP server architecture that I have, and also authentication and security best practices for MCP server plus Azure ML, plus Microsoft Foundry. Remember, the name has been changed to Microsoft Foundry and Azure ML. Then we'll take you through the MCP integration with Foundry and Foundry agent and ML pipelines. Then I'll draw up the question and answer and then conclusion. So introduction, I will not speak so much to this, but MCP servers is a protocol, model context protocol that enables your system to have the LLM systems. By the way, it extends the functionality of LLM systems and also bring in security, act as a security bridge that makes sure that your agent or your LLM does not directly interact with your enterprise systems. And that is a very good one because it helps eliminate the security vulnerabilities while also giving your LLM or agent an extensible capabilities to reach more tools and deliver best services to you and your organization. So through this integration, MCP servers that who is now acting as the middleware between your agent on the Microsoft Foundry and your ML pipelines, you can orchestrate the cloud systems and be able to deploy ML pipelines in seconds. Now, this solution are built using Python and Azure SDK, and by so doing, I'm able to achieve and build a very seamless MCP server that responds and call and that enables your agents on Foundry to call tools seamlessly and in real time. So I'll move down to the requirement for this. I'm going to be sharing my screen and take us through the GitHub workspace and even my Visual Studio Code. So on the Azure side, you need to have a subscription. It's very important. And Microsoft has a free $200 credit that valid for about 30 days. And you can actually leverage that to develop your skill. So you need to have appropriate permission in the Microsoft Foundry agent or AI services. Azure AI services need to at least have Azure, maybe Azure AI role like developer, and that is managed by the intra ID RBAC permission. So you need to also have a model deployment tied to Azure OpenAI already in place. You can leverage the GPT-4o or GPT-4.1, 4.1, or the higher one. A lot of them are coming up. Then they must be deployed via Foundry project. The Foundry project is like a container that houses both your agent and your model. The model is behind the scene, while the agent, in this case, play the front row, interact with the user, and then call tools due to the extensibility capability that it gets from the MCP server. So on the MCP side, you need to have a running MCP server, either hosted locally or on the cloud. Of course, there's one caveat when you're running your MCP servers. If you're running MCP server on your local machine, you cannot directly interact with a Foundry agent. Your MCP server needs to be hosted on Azure services like the container app or app services or Azure Kubernetes service before you can work. But there is also a workaround if you want to do it for development purposes, which we are going to see today. How can you make your MCP server, the URL, the local host URL, to be accessible by a third party or by someone who is not directly connected within your network or who is not accessing your local system? So now you need to have either you are going to leverage GitHub MCP server or you build your own, like in this application, I built it using fast MCP, fast API, leveraging Python stack. So you need to have accessible HTTP localhost, and you need to really label your MCP server with a unique name that you can identify. You need to also set your auth headers that MCP needs to reach and all that. So moving forward, the setup step are now what you do first when you get your environment, you made the requirement. How do you now set up the whole of this project? So you need to have a resource on the Foundry created. It could be a hub, and maybe you can leverage project. The hub, leveraging a hub will enable you to have an extensive access to open source models, while leveraging Azure Foundry resource will put you at the middle where you leverage Microsoft own models while deploying them. So now you need to also deploy the model, like as I mentioned before. You need to capture your project endpoint and key, but then you need to be careful how you handle them. I'm going to speak to this. So you need to create a local project directory. Most of us knows how to make directory and all that. So you need to create and activate a Python environment. Maybe Python environment is very important because it isolates your project. It gives from the global environment, it gives you a place for your project to work on, and you can relax while not affecting other project you could have. So you need to configure your environment variables. Do not hard code your secret API keys and endpoints. You need to save them either locally and add them to git ignore before pushing your code to the GitHub. You need to also build the integration files. Guys, we have the integration files I'm going to show us today. It consists of 3 files: the MCP server itself, Foundry agent, and Azure ML bridge file. So I will take us through the architecture, how it works. This is a simple architecture diagram, and that gives you and I the 3 layers service of 3 layers architecture of application. From here, you can see that from the integration first, mind you, this architecture, I intentionally omitted the user layer, that is the user input layer. Of course, before a user can interact with it, there must be an input, either through the natural language, where you directly ask your agent question to deploy ML pipelines. And one good part of this solution is that it is scalable. If you pick the code from my repository, you can clone it, then extend it by adding other tools. You can add the DevOps, you can add a tool to deploy DevOps pipeline using your MCP server without having to do that manually or on your own. So now you can see that the first thing first that I deployed was to grant myself the permission on my subscription and the resource group. Then I get myself an AI role through the RBAC service of the Intra ID. Then deploy a model, Azure OpenAI GPT 4.1 model. Then create my Foundry agent. Mind you, now the Foundry agent is making an HTTP call to MCP server. Is trying to deploy a pipelines to my Azure ML workspace. But my Azure ML workspace is actually an enterprise environment where I do not want the agent to go straight to it. So this is where the MCP server come in as a bridge to make sure that everything is are verified before the pipeline's deployment is initiated. So what it does is that there is a tool. It's not like a direct two-way process. Not that the MCP server is taking anything back from or is taking something from the agent. No, instead, agent is the one reaching out to this. Then the MCP server will respond with a feedback, the giving the result and all that. Then after that, it will deploy it will call the Azure ML tool. Remember that MCP server is made up of tools. You can add a lot of tools. Like I'm going to show us how I have about three tools that are added to this. So at the end of the day, what you need is for you to be able to make sure that when you ask a prompt to your agent, maybe deploy my ML pipeline and hit your send button on your system, the agent send that query. And that query will land on the MCP server. And it must be verified before it can, there's a protocol around that, before it can release and then deploy the pipeline, then get back to the user that the pipeline has been deployed. Remember, the prompt comes into agent through the user who use the natural language processing to be able to ask the user the agent question, and the agent do that. So now the approval stage is the The MCP here plays a huge role. What it does is that it receives this request. After receiving it, it validates it. Then after validation, it approves the tool calls. The tool call will go now to the Azure ML tool, and then respond back to the user that your pipeline has been deployed. You see, look at the pipeline name, the job name, and all that. So now we also have, I'm not sure if you have any question, but if you have any question, let me know. So we have the authentication and security best practices. So as I mentioned before, these are very critical issues that the beginners might make mistake, and it shouldn't be taken for granted. Do not hard code your credentials in your code base. You need to be careful about that. Then another one is also you need to use the environment variable when developing locally. But in production, you are advised to use a service connection, a connector like say Azure Key Vault, so securely manage your secret. And also, you need to implement a strong error handling logic for authentication and permission failures. This is very important for you to achieve a scalable MCP system. So you need to also enable automatic key rotation. Right now, I have, let's assume, I'm developing my own solution and I'm using my keys. The keys must maybe have fallen into wrong hand. I need to go back and rotate it. Then that can be automated. So you need to enforce strict input validation to safeguard MCP tools, Foundry agent, and Azure ML endpoint against injection and malformed request. This is also very important. I need to safeguard that. Then you need to, I think I'm done with that. So I don't have much slide. We need to jump to the demo interface. What is this? What is it that you want to even look at? Because I already built the app just for me to walk you through. So you can take the sample of the code, deploy in your environment, extend the capabilities for your work or for not really your work, because this development, do not use it for production, for your own learning purpose. Anyway, so the objective is to integrate AI Foundry agent, MCP server, and Azure machine learning, so that AI agent can safely trigger enterprise ML workflows through standardized tool calling mechanisms. Then how does it work? The Foundry agent interprets user requests and calls MCP tools. The MCP server executes Python functions and connect to enterprise systems. The Azure ML pipelines can run real machine learning operations and return results to the user. So that's what we want to do. So let me go quickly to my own code. So right now, I have my code environment. You can, as you can see, I'm going to speak to some of these files one after the other. And let me enlarge my, at least maximize my code and all that to be able to be visible to you. So let me see, Command plus, okay. I think it's clear now. So I am in my project subdirectory, which is MCP Foundry ML. Right now, I have the architecture diagram I just presented right here. And I have some docs that will help you to get started while implementing this in your environment or in your own learning space. I have script. Few things you need is that you need to deploy a compute that works behind your ML workspace for you to be able to host your ML jobs and pipelines. So this is what the script does for you. Then we also have I also have set up scripts that check that everything is working fine, that you have all the endpoints like the subscription ID, the workspace, the ML workspace name, endpoint, and all that. So for the source file, I've defined the Foundry agent, and this is the bridge file which I'm going to speak to. Now, the bridge is the one that acts as the connecting point between the agent and the Azure ML pipelines, and the MCP server is sitting right in the middle. Right now in this place, if you observe, I want to go to the data class here, is what triggered the connection to the ML workspace that I've created on Azure. To create an ML workspace, you can deploy a script to do that, or maybe you can just walk to the portal and create it manually. Then now what does it do? Azure MC class, I defined the MCP Azure bridge. This is the helper class for submitting pipeline jobs. So when a user submits the job, it returns a JSON payload that calls my pipeline in the ML jobs location, and then it trigger a pipeline deployment. So that is for bridge. Now the client is what speaks to agent itself. This is the agent client. That is a Microsoft Foundry agent. Now let's take it through here. So Microsoft has changed the way if your authentication to Microsoft right now, the one I'm using right now is I'm using the default Azure credentials. But for production and best practice, if you are not using this, you can actually use the what's called service principal for authentication. But I think this is also a very good one. So you use the default credentials. So my server URL is called, where the tool is called itself is my local host port 8000 MCP then call. This is my API daily server URL that actually expose my tags within my MCP server. So all this, if you go through the code, you're going to know what it means, and also added the README file for you to go through. Then the MCP server itself, I have tools, like I mentioned before. One of the tools is to deploy the Azure ML tool. What this does, this is actually the one that handles the deployment of that pipelines. So this is the MCP tool to call the pipelines. Now, if you come to this point, you see user has submitted a pipeline, and what does it do? Now, I have passed a simple user input so that when the Azure AI Foundry entry point, this is a server for agent entry point. Once it starts up, since I'm developing it locally, I'm hosting it locally. I'm not deploying it to any Azure Container Registry, or so I'm not able to interact with Azure with Foundry agent directly. So instead, I have passed a simple user input on the MCP Foundry agent, which is the entry point for the MCP agent in this case, so that whenever I run this server, it will prompt me to ask to pass a prompt in a natural language, just as if I'm using the agent playground. So that is one of the ways you can also use for development if you do not have the opportunity to use the cloud or host your resource. So in case if you have any question, let me know. Damilola, please watch out in case there's any question. So I was explaining this. One of the tools is to call the MCP, the bridge file, which I explained before, and then give the user unlock a successful submitted Azure ML job message and the job name. Then if there's any error, there's an error handling here. It will return that there's mixing variable, that is from the environment variable. There's no project endpoint, Foundry agent project endpoint, or there's no model name, all those stuff. maybe I'm not defining a lot of things, so it will fail. But if it also there's a space for me, because not all ML works jobs are for production. Most of them are for experimentation and all that. So I also added a step here to also take care of when a user is simply testing or experimenting with some of the workloads. So it's one of the tools that I'm going to call. Then I also put up a utility tools. This utility tool is just to, when I was building the solution, just to enable me to test if the MCP server is also working for me as well. So, and that led me to defining my .http file, which I use Postman. So now another thing I want you to note is that you can actually initiate a REST client call directly from your VS Code without having to go to Postman interface. All what you just need to do is to install the REST client extension in your VS Code. And also you can actually also use a Postman directly also within your VS Code by installing the extension. You want to make your HTTP request, define your request as post, put the server URL, and then define the content type as application/JSON, then define the body and all that in raw JSON format, and make your HTTP call. So this is one of the ways you don't need to leave your VS Code while doing all these things. You can actually do them in one place. So going back to what I was saying, so right now, the utility to enable my MCP server to welcome my audience. Right now, you are in this call, and I can actually just test it because I have installed the REST client extension. So I'm going to go ahead and start my MCP server. Right now, it's not running. So I will do that by using my Python. Down the MCP server has a startup file, the entry point. This server file here act as an entry point. My main file is defined in the config.py and the main.py. This is the main MCP server file that I have. So I'm going to be running this as a startup file and the entry file as well. So, but make sure that you have activated your virtual environment. If you look at the prefix here, it means VENV, this virtual environment. To do that, if you're on Mac, you just have to use source slash .env/bin activate. Then you need to enter. Windows is just for you to. I've forgotten the command, but if you look up for Windows, you just need to note how to activate that. So once you activate this, will come on live, and you can be able to actually run your application. So I'm going to say Python server.py. So it's going to start up the server file for me. And right now I am running it locally. No one else have access to this app except me. So if I send you an URL, it will fail, it will load. So how do I make sure that you are able to load it? I'm still going to come back to that. So now if I go back to my file right now, as you can see, because the server is running, they send HTTP request as command live. Now I want to greet my audience. Mind you, this is powered by my MCP server. Now I'll go there. If I run it, the test will pass. Same way I will have defined, make the HTTP call in Postman is what the extension has enabled me to do within my VS Code without leaving this interface. So he said success is that, hello audience, that is you is watching me. Welcome to MCP Foundry ML integration section by Moetuk, and enjoy exploring the capabilities of MCP server. Then the error is no, there's no error. And the success story, the terminal return 200 as okay. So now another one is that what if I want to, let me walk us through the utility tools again. So when I was testing it, I had the I had to put up 2 files just to test under utility tools. And one of them was to greet my audience, and which is this one. Then another one, no, sorry, let me go there. So first one was to greet my audience, which is this. Then the second one is to just do multiplication of numbers, addition of numbers, and all that. And all those things, I'm able to test them here. I've already defined the code file here. So now I want to just test the add numbers tool. I can just make the request now. If I change my figure from maybe 5 to 20 to 10 to 20 and save it. I also implemented auto refreshed, reload. You see, my terminal has changed now, the file has changed, and the server has restarted and picked up that changes automatically. So now if I go back and run my HTTP request on this number, it will give me 25. So all these things are powered by the MCP server. Now let's go back to the real one which we want to look at. Now I'm going to go to Azure, permit me. So this is my resource group that's hosting all the workloads, hosting the ML workload and even the Foundry agent and all that. So I'll go to, let's first of all walk us through the Foundry workspace and resource. Right now, this is the resource that I have created, and I have my project deployed within the Foundry resource. And now, based on what we've been hearing about best practices for you to protect your workload and all that, you need to, on a normal one, when you are doing it for production, you do not need to allow any internet access. That is where the private endpoints come in. So in that case, you need to create your what's it called? Create your virtual network, define a dedicated subnet, usually Azure AI Services subnet. Now, I think that's a unique name for it. Then direct all your traffic to that endpoint. So nobody anyhow can access your resource, and it's been very practical and applicable to enterprise systems. So all these things will help you. Now you need to also encrypt your key to either with your key or your alarm. Like in this case, I'm using Microsoft managed keys. But in your own environment, you can use customer managed keys if you feel that that is safe, depending on what you want. So that's how this one. Then for endpoint and keys, I can just pick my key. Usually, you use key one for those starting up with Foundry. Key one is used because key two is a fallback key. So for you to have for you to ensure the effective response of your or interaction with your Foundry resource, you need to use the key one. Key two is usually like a backup key in many cases. So let's go to the Foundry portal to explore how the agent and the model were deployed. So this is very straightforward. And mind you, can also use Terraform to pass through the CI/CD pipelines and deploy all this. But the agent, for now, I'm not been able to find. Not sure if I'm able to find a Terraform provider for deploying agent. I'm just going to check the Microsoft Docs to show. But you can deploy. Model has the Terraform provider for you to use. So right now I am in this interface. This is my agent, and you need to pick this target URL, which is the endpoint. And if you observe, while we were here, there's an endpoint here. So this may not give you accurate result of what you want when you're interacting with the agent. So usually I use this. So the key is also the same here. The key one is the one displaying here. So that is that for agent. For the model, you check everything. And okay, this is the model. Okay, now let's go to agent. So the agent I have here, mostly the naming convention is all about what you need to do. There's no but it's always good to you follow your organization or your personal naming convention. In this case, I'm working with MCP Foundry and Agents. That's why the name is like this. So you need the agent ID. You can do a lot of manipulation by passing out the instruction, defining agent description, and maybe connecting to a knowledge base, which you have somewhere, maybe on SharePoint or your database. Then some actions for you to trigger. If you want to define a flow, a workflow, using either Power Automate or Logic Apps. You can use this action button by adding the actions, and Logic Apps as a function also here. So all these ones are extensive way of working with agents. We are not going to focus on that. But then this is a management center. We can play around and get to explore how agent works. So with that, I'm able to view that. But if you observe, I cannot directly work with I cannot directly interact with my agent on this platform. So I need to go back to my VS Code right now. But then before I do that, let's go back to my resource group and show us through the ML workspace that I have deployed. So this ML workspace, I've already added a script on the code base, which let me look for my own the repository and share with us. This is the repository. So I was just making the last commit when the other speakers were speaking. So you need to just take a clone of this, a copy and clone to your system, and then start working. All the README file you need are here, with the diagram are also here. So I'm going to share this in the chat. So you just clone that and use it to work. Now, if you have any question, let me know. And if you have yes, sure, Victor, I'm pasting the repository right in the chat. So you just need to take a clone of that. All the instructions, I've defined them in how you can integrate it. And mind you, you can extend the functionality to handle your, I'm still going to extend it, by the way. I'm still going to extend it to handle CI/CD pipeline for DevOps and other things. So there's no limit to which you can make your enrich the capability of your MCP server, of course. So now going to this ML workspace. I have to enter the studio. Then within the studio, I have some jobs that I preloaded, which I test. So now my jobs, I have about 2 jobs right now. I have about 3 jobs in the past history. Their status are completed and all that. So now let's go back to, we have seen that we have 3 jobs now with completed status. So how does that MCP server that I have built help us to talk to this workspace? Is what I'm going to take us through right now. So coming back to our VS Code. Right here, I have my MCP entry point for my agent, Foundry agent. So I'm going to walk us through how this is simply the entry point. The main agent client file is held in the client.py file. So this is where all the authentication takes place, and speaking to the .env file, which hold the variables. I'm not going to expose that for security reasons. So, but then this is a sample file which you can follow. I replicated what I have there, but here without my credentials. So you need to follow this. This is pushed to the GitHub repository. So now I'm going to this. I'm going to open up a new tab, a new interface here. And what do I need to do now? But then before I go ahead and do this, let's test our ML, Azure ML tool to see that is working. Now I'm going to make an HTTP request call. I can do the experimentation to just see if it's working. I'll just click send request. Just hold on. Let me close some of this stuff. So the request has returned a success status here. Be careful, because while experimenting, you could possibly be exposing your subscription and everything when you're making an HTTP request. That's another thing you need to be careful, watch out for, and that could be dangerous. So, and that has returned a successful message. And if I go to my this workspace and look at the pipelines, I have here. So the pipelines is named as MCP Foundry, just experimentation. And what happened? This is it. I just run them. So let me go back to this place. Now we have seen that is working. So now let's go to workspace. The main one, that's in the production, the pipeline deployment itself, to do the HTTP request. Now I send this request again. So it will respond. Sometimes it takes a while. Now look at the status here. Success submitted. The job name is kin_wall with a generic name. The status is not started. That's a response from my MCP server that the job has not started. Now, and the experiment name is this pipeline job. This submitted successfully. I've submitted the pipeline job right now as I run this. So if I go to, let me take this name and see something with us now. I go to my pipelines or go to my jobs. You see that the request I sent now came here. So if you look at, let me check again. Which one? Look at the one I just did now. It shows completed. So now if I go back to my this thing, let me go back to my VS Code. And then I now check this one. This one shows get job status, get the pipeline status when it's completed. So I can close this one, get the job status, and then it will report back this job status has completed. Of course, in that this thing, it shows that it's completed. But then I have some errors here that I could not retrieve the job this thing. So what do I need to do? I need to replace this name, the job name, with an active job name. Maybe I must have, maybe with a completed job name, but or with a job name that can be found within my ML workspace. Must have deleted this particular job name. So I need to go back here and pick a job name that I know. Maybe I can just copy this one. So once I copy that, I will come back here and then paste my job name here. So once I do that, I save it. My MCP server will automatically be restarted right now. So I can now go again and send my request. So now the job status is that is completed. And if you confirm from the Azure ML workspace, the job status also being completed. Now let's go back to starting the Foundry agent. Now I will open another. Okay, I've already opened that. This is a MCP server running here, then this one running here. So I've already opened that. So I now say, okay, I will just run Python MCP dash Foundry. Sorry, it's not dash, it's underscore Foundry underscore agent.py. So this will start up my Foundry. And like I told us earlier, due to the fact that my MCP server is running locally, I can't directly interact with the agent on the agent playground. That is why I added an input prompt, the user input prompt. So whenever I start the entry point server for the agent, it will ask me for something. And I can just simply ask this message. Look at the default message that I define. I use the server to run this. So you can say, okay, we'll just shorten it, run Azure ML pipeline. It will deploy a new pipeline. Remember, what we have here, let's take note that we have about 1, 2, 3, 4, 5 jobs there. So run ML pipeline. I'll just pass like a simple prompt. So now it calls the tool. Look at agent calls MCP server. Then this next step is run a pipeline. So the successful message is that it has created. Now, if you look at it, the job name is this guy. When we go to the portal, we will find it. And what happened again? The status is that it's not started yet. The job is going to be triggered automatically from the workspace, ML workspace. Now, if you go to this, if you come to this guy, that what the command I just the prompt I passed now to my agent is the reason why why I'm receiving this notification. So now, if I check that job or refresh, it will increase that 1, 2, 3, 4, 5. So I can search for that job name that I just copy. We'll find it here. So this is how that is automated by the MCP server and the agent. Okay, so that's that for that. So what if I want you to also have access to this my local system? I think this is going to be the last part of my presentation. So I can go to NGRock. NGRock is a proxy server that enables you to have a proxy connection between your local and the internet. So yeah, but you need to install it. And you need to also sign up. It is free of charge. There is a free plan which I'm using now. It's really cool. At least is doing what I want you to do. So without having to pay. So you can sign up for the free plan and just use it to experiment. To do that, you need to go to, let me look for, just Google NGRock on the internet. Then come to your system. I can stop this. I need to stop this one. I need to stop it so I will be able to start it so you see it. Now, if you come to your terminal, open to your terminal. If you are using a MacBook, is Brew install NGRock. Then if you are using it, then you can validate it. Then you need, once you install it, you need to activate it by providing the authentication code from the sign up page. When you sign up, there is going to be a one-time authentication code. I think it's not one time; it's always there for in your account, so you can just use that to authenticate. Now another one is also that for Windows, you can use, I think, Winget install NGRock will do the installation. So after it has installed, now if I want to access my NGRock, I will just run this NGRock HTTP because my server is running on port 8000. So with this, it will start up my NGRock. And now do I now send this to you? Look at now, it has mapped the URL to my local URL. And with this, someone who is not within my system will be able to access this MCP server and see how it works. Now let's even copy this and go to go to a web browser and see how the tool is called and all that. So I go here and then paste the MCP server link. So now this is my MCP server. How many tools do I have? I have about 1, 2, 3, 4, 5 tools. So as I mentioned before, you can keep on increasing these tools based on your requirement for your training and learning purpose. So now for my tools, I can go here and look at the raw API endpoint and all that. So I can also explore the docs, which will give you other further information on how to make the HTTP request and all that. So description, tool call, then the MCP call. So these are these are the request body. So with that, if I share this URL with you, you'll be able to access this particular page right now. So I'm putting that in the chat. So if you have any question, you can reach out to me or you can drop it in the chat section. At this point, I think we come to the close of this presentation. So feel free to take a clone of the GitHub repository. If you feel like you want to contribute, create a branch and put your bring your changes, I can always approve it. So that is how you can go on implementing and integrating your MCP server with enterprise system like ML workloads and all that. Thank you very much for your time. Dami, are you there?
Yes, I am. Thank you, Mr. Moore. Thank you for this session. And thank you, everyone, for staying to the end. We have gone through different topics on the MCP server. And like Mr. Moore said, this is part of the Seasons of AI by the Azure Nigeria community. So please feel free to watch every session again. If you have questions, feel free to reach out. And you can also join the community. Thank you so much for your time today.
Thank you, everyone.
All right.
Bye.